Hello friends, in this video we'll be taking a look at the autosomal DNA results, predicted phenotype, traits, and even ancestry results of an Anatolian Neolithic farmer woman from Barcin in Turkey. Her mitochondrial lineage is U3, and this is where she is from. This is the city of Barcin in Turkey. It's located in northwestern Anatolia. Let's go ahead and move on to her autosomal DNA results. We're gonna start with her noshacot results, what she looked like. This seems to be what she looked like. So she's got light brown or dark brown or hazel eyes, but it looks like the highest percentage here is for light brown eyes, 61% likelihood of light brown eyes. She doesn't have green eyes or blue with 8% or blue. That's pretty much out of the picture, but she could have hazel eyes. There's a 10% likelihood of that. When it comes to her hair color, it looks like she's predicted to have black or brown hair. There is very low likelihood of red or dark blonde or light blonde hair. When it comes to her skin color prediction, she's got intermediate or dark skin. So it looks like, although the intermediate is a little bit higher in terms of the percentage for intermediate is higher than the percentage for dark. So she most likely has intermediate skin, although there's also a pretty large chance of dark skin for her. When it comes to her predicted eye color, this is her predicted eye color with noshacot, with the web version of noshacot. This is the picture that is displayed when you score what she scores. And for hair texture, she's actually predicted to have curly or wavy hair. She probably doesn't have straight hair, although that's also quite possible. And she definitely doesn't have kinky hair. So her hair texture, is most likely curly or wavy. So she most likely has curly or wavy hair. Let's go ahead and explore what her genotypes in OCA2 and HERC2 is. Let's scroll back to the very end, and it looks like she has blue eye haplotype 1, so she has BEH1. She's got this genotype, which is also predictive of BEH1, and she's heterozygous for BEH2, and she does not have BEH3, and she does not have BEH4. So it's kind of a typical, you will find, in Europe, you will find a lot of Southern Europeans with typical pigmentation-related variances. This heterozygous for BEH2 is very typical for Southern and Central Europeans. For Northern Europeans, like north of, say, Germany, in Scandinavia and Finland, for them it's really uncommon to be heterozygous for BEH2. For them, most of them have homozygous derived genotype for BEH2, but in Germany, in Central Europe, in Eastern Europe, in Western Europe, it's a very typical genotype. So there's a lot of Europeans who have similar coloring genotypes to this woman. Let's go ahead and see what she scores for the ethnic calculator results, what ethnicity she resembles the most. It looks like based on 445 SNPs, she most resembles funnel beakers from Ansarbe. Funnel beakers are Neolithic farmers from Scandinavia. Followed by that are bell beakers, followed by that are Bulgarians, Spanish, Russians, British, global or amphora culture. So it looks like she's quite northern. It looks like she resembles these Central European farmers and Bulgarians and Spanish people, moderately somewhat, and she also resembles bell beakers. So she's quite Central European in her ancestry, what she resembles. Keep in mind, this is not G25, because I have people in my comments who are saying, where do you find these samples? It doesn't look like a typical whatever, Anatolian Neolithic farmer, whatever. Because it's not G25, it's my own calculator. I'm showing you my own calculator. I'm showing you her results with my own tools, not anything else. Alright, let's go ahead and check her polygenic risk scores, what she scores for diseases. It looks like she's got above average score for schizophrenia, very rare score for Anatolian Neolithic farmers. I've been noticing a lot of below average scores for schizophrenia. Most of them have below average scores in Anatolian Neolithic farmers, but she has got above average score for that, which I find quite surprising. It looks like she's got a below average score for type 2 diabetes, below average score for Alzheimer's, below average score for multiple sclerosis, really good. 7 risk variance for breast cancer out of 12, definitely not good. That's very atypical. We're going to explore that and see and find out what contributed to this. 11 risk variance for testicular cancer out of 16, definitely not good. Also very atypical. We're going to explore and find out what contributed to this. 0 risk variance for celiac disease, very good, very typical. 0 out of 4 for GSS, very good, very typical. 9 risk variance for Crohn's out of 22, definitely very atypical, definitely very strange. We're going to find out what contributed to this score. So we have to keep in mind for breast cancer, testicular cancer, and Crohn's. We're gonna keep those in mind, and we're gonna, as we scroll through the monogenic traits, we're gonna focus on them. It looks like she's got AG in Komets-Valmet variation and TG in MAOAs. So she's got heterozygous genotype in both the variations that have to do with warrior versus warrior. She's probably got intermediate speed of dopamine reuptake and intermediate dopamine levels, therefore. It looks like she's got 2 derived no-go learner variants at DRD2 Pro for 19 Pro, which is pretty stereotypically European, right? So she's definitely got less dopamine D2 receptor sites in the brain. I'm somewhat surprised this is her genotype because she did score above average for schizophrenia, and this does play a part in the schizophrenia prediction. So it looks like she's got a reduction in the number of dopamine D2 receptor sites in the brain, a reduction in the risk of schizophrenia, and increased likelihood of no-go learning, which is the ability to withhold a response when it's not warranted. And I do need to remark once again, this is a very stereotypically European genotype to have. It looks like she also has short form 5-HTT-LPR and does not have a decrease in the risk of depression. Once again, very stereotypically human genotype. Most humans have short form 5-HTT-LPR. Little fun fact about myself, I have long form 5-HTT-LPR. For lactose persistence, it looks like she does not carry the European lactose persistence mutation. If she took an ancestry test, it would say, hey, you're lactose intolerant. For OXTR and empathy gene, we're only going to look at this variation because this is by far the most important one. It looks like she has 2 sociopath variants for reduced OXTR expression and lack of empathy, so more sociopathic than not. For diabetes, it looks like she does not have type 1 diabetes. For hemochromatosis, it looks like she does not have any risk variants for hemochromatosis. For Alzheimer's, nothing important was found. For multiple sclerosis, it looks like she's got this genotype, which protects from multiple sclerosis. Very, very interesting. I'm seeing a lot of samples with this exact genotype, Anatolian Neolithic samples, which protects from multiple sclerosis, and I'm not sure what the deal is because it's a rare genotype. It's not really common. She's got the G allele here. For myopia, I typically skip myopia, but we're going to talk about it now because she's got the G allele here, which is uncommon and leads to lower risk of myopia and slightly better eyesight. It's also a very stereotypically European allele. No micro P, really good to see. It looks like she's got 2 fat gene variants in FTOs RS9939609, much higher odds of obesity and sleep apnea. So she's got this genotype which predisposes her to be overweight. She's got a mix of muscle types, likely more sprinter than endurance athlete, and 1 variant for increased pain sensitivity. And she does not have East Asian EDAR or the East Asian flusher mutation. So it looks like she doesn't really have any East Asian genetic traits. We're going to skip drug response. We're going to skip albinism. We're going to skip familiar Mediterranean fever. We're going to skip MTHFR. Now we're going to move on to cancers. So for breast cancer, she's got a lot of risk variants for that. It looks like some of them are in niche variations. It looks like she's got 2 here, 1 here, 2 here. So it looks like she's got some variants for breast cancer, which are really uncommon, like these 3. Alright, and for testicular cancer, it looks like she's got this genotype, which leads to 3 times increased risk of testicular cancer risk for men, and this genotype, which leads to increased risk of testicular cancer. So 2 out of 3 most important variations for testicular cancer were found in the file, so it's definitely quite an alarming result in terms of her score. Leukemia, looks like she's got moderately increased risk of leukemia. Interesting. We're gonna skip rare diseases. We're gonna skip celiac disease. We're gonna skip allergies. We're gonna now Crohn's disease. Okay, this is good to see. For Crohn's disease, none of the important stuff is found in the file, and that's really good to see because the important stuff here, these 3 are by far the most important variations. If she had any risk alleles in these 3, that would be concerning. So her score for Crohn's, where she scored, let's scroll back to the end, to the beginning. For Crohn's, she was scoring 9 out of 22. None of those 9 risk variants are in the most important 3 variations, so they don't really matter as much as they would otherwise. Alright. Canavan syndrome, it looks like no risk variants for that, really good to see. HIV and AIDS panel, once again I'm seeing this genotype, which is really uncommon in modern people. I mean, it's just really uncommon. But a lot of these Anatolian Neolithic farmer people have this genotype, which leads to 90% reduction in HIV viral load. So I'm not sure what it is about the specific genetics of these Anatolian Neolithic farmers from Barcin, but among them this seems to be the most common genotype, whereas among people in Europe or among modern humans, it's found at a frequency of like 4%. So I'm not sure what causes this. It's definitely a very interesting find that I'm noticing here. Well, that's pretty much all I wanted to say here. Thanks for watching my video until the end. I've reached the conclusion of the video. Leave a like and subscribe if you enjoy it, and also you can download this file in 23andMe format from link which is in the description of the video. Thanks for watching, goodbye.